Muhammad Fadil
Kok
from
busy?
Indonesia.
Well, hello everyone. So, my name is Fadil. I'm
Okay.
coming from University of Indonesia, and this is my fellows, Asha, Karin, and David. So, okay, let's start with this map, right? So, imagine that you live in England, and you have the factories in the center city of England, which is London, and you have to distribute all the products in the 5 different cities, right? Well, a lot of constraints such as the truck capacity and the demand that have to be fulfilled, and also the number of fleet that you have to deliver, a lot of things. Well, this problem seems very simple because what you have to do is you have to assign each fleet or trucks to its ship to point. But how about if you have a lot of factories, a lot of ship to point, a lot of cities that you have to deliver your products or goods with, because this will make pretty harder, right? Because there's a lot of variables, a lot of constraints that happens. Well, this is how exactly the optimizations are really working. It's because you have to achieve the optimum cost as possible. Well, in fact, there's a lot of examples of optimizations happens around the world, such as facility planning, facility layout, or manpower planning, so how you actually manage your human resource in your company, and also the maintenance scheduling or plannings, and also the flight congestion that you probably commonly see so far in the airport, and also the capacity plannings. Well, in fact, how to deal and how to solve the optimizations is by doing this. But with very boring, very old way, you have to build a mathematical model, and you have to solve this kind of thing. You have to identify what kind of objective functions, what kind of variables, what kind of input you have to put in order to solve this kind of optimization things. Well, in the end, the optimizations actually have to deal with 3 main things. The first is variables, which is x, y, j, and ij, and etc. And also the constraint that you have to deal with, because there's a lot of constraints, dozens of constraints that happens, and it is a very broad way to think and to study, especially in university level of students, to study about the optimizations in very broad way, right?
The realization of optimization concepts and theory into other formulation create a large area of applied mathematics. Basically, because of this variety and complexity makes this optimization concept into university level of rise from fields such as engineering, mathematics, economics, and business. However, because of this complexity coming from different kind of model possess different kind of rules usage of each model that yield in the end different kind of value for the same problem, this makes stressful situation for many students and often fail them to solve the problem with the most compatible model for this kind of problem. So, back to the root. The basic question we need to answer is why it is very important to learn about optimization and specifically for university students to understand the concept and how to apply it in such problems. The reasons is on 3. The first one is obviously to get good grades. Okay. The second one is to get maximum profit or expenses, minimum concept from selling hamburgers. And the third one is, okay, let's be serious, to make effective use of situation or resources. Ladies and gentlemen, we are here united because we have the same belief that the most effective way to solve conventional educational problem in understanding a concept is through educational games. This mainly because games give experience and experimental learning to the players so they can digest the situation and construct the structure or even better. And to answer these challenges, we present you Resources Go. What is Resources Go? Resources Go is a computer-based game of optimization that tackles basic to advanced model of optimization with theme of transportation problem and maritime scenario that order players to send resources from origin to the destination. Yet of course the purpose is to gain maximum profit.
So what do we want the players to achieve here? According to Bloom's taxonomy, our game has the objective to help the player analyze the idea of the optimization. So we want the players to be able to identify what kind of optimization model they are facing and which method is the best to solve them. And here are the 3 key elements in designing our game. First is reality, where we combine the complexity of ports and maritime logistics. And second is meaning, where we use the calculation mathematically to solve the problem, and lastly is play, where we bring back the player to the medieval era to add the fun part to this game. And continuing the fun part, in this game, player is positioned as a marquis, where he is responsible in regulating the border area, including the ports of a kingdom named Emerald of the Equator. This marquis is supposed to fulfill the king's task and also increasing the prosperity of the kingdom. And despite of being set in the medieval era, we use real map of Indonesia as the emerald of the equator. Why?